Hi, my name is Molly Bartlett or Miss Bartlett. This lesson is for first graders and it is based off of the investigation method posed in chapter 4 of the text. So this will be happening around the middle of the year and it has to do with the commutative property of addition. I'm assuming that we have talked about other properties of addition in previous lessons, and we've talked about the commutative property, but we haven't talked about why it works. So and then we're gonna pretend that my notebook is a whiteboard because I don't have a whiteboard right now, but yeah. Okay, first graders, I need you guys to put your thinking caps on, get your detective spy glasses out, and we are going to learn about why the commutative property works. So, we know what is the commutative property? It's the idea that A plus B is equal to B plus A. Good job, first graders. So, why can you flip it around? Why does it work only for addition? Does it work for subtraction? We're going to try all of that out today. So I want you guys to imagine that I have 4 scoops of ice cream. 1, 2, 3, 4 on this little cone. You see it? There's my ice cream cone. So I want you guys to pretend that I have 4. And then my friend tragically can't finish her ice cream. And she says, Miss Bartlett, I need help. I'm going to give you my extra scoops of ice cream. I'm going to make them extra big. So she gives me 2 scoops of ice cream. How many scoops of ice cream do I have now? Let's write that out as a math problem. So I have 4 scoops of ice cream, and then I add 2 scoops of ice cream. So how many scoops of ice cream do I have? 6. Good job, first graders. So I have 6, right? We like our number 6. So why can I have 4 scoops of ice cream and add 2 to get 6? Can I have 2 scoops of ice cream and then get 4 and still get 6? Okay, so I'm going to start with my ice cream cone. I'm not the best at drawing, first graders, but it is okay. So I'm going to start. I have 2 scoops of ice cream. Here, I'm going to redraw it over here. Here's my new ice cream cone. And I have 1, 2 whole scoops of ice cream. And again, my friend says, Miss Bartlett, I cannot finish my scoops of ice cream. I really need you to have them. I said, okay, how many scoops do you have? She said 4. So then I add 4 scoops of ice cream. Whoa, it's kind of leaning over. Look at that. Whoop. It would probably fall over, huh? So I have 2 scoops of ice cream. And then I have 4 scoops of ice cream. So how many scoops of ice cream do I have? 6 again. Good job. So, the reason why, does anybody know why? I'll explain it to you. So, the value that you end up with does not change no matter what order you do your math in. So you can have 2 and then have 4 and get 6. Or you can have 4 and then 2 and then get 6. Now, do you think this is going to work with subtraction? Why? Let's try it out. Here. Let's erase the whiteboard and then let's try it again. So, let's say I have 4 scoops of ice cream. 2, 3, 4 scoops of ice cream on my little cone. And then tragically, it falls. But not all of it. Only these two fall. How many scoops of ice cream do I still have? I still have 2, because we can see that right here, right? So let's write that as a math problem. So we have, how many scoops of ice cream did we start with? 4. And then how many did we lose? How many scoops fell off? 2 scoops of ice cream. And how many do we end with? 2. Correct. Now, let's try to flip the numbers around. So let's say in this marvelous scoop down here, I have 2 scoops of ice cream. So I'll start. 2 scoops. Let's say, tragically, I lose 4 scoops of ice cream. 4 scoops. How many do I have? 2. And I lost 4? I can't do that. I can't take 4 away from 2. That would mean that I have less than 0. I'm going to tell you guys a secret. It equals -2. Isn't that a crazy number? We'll learn more about that another time. But I want you guys to play around with different numbers and tell me if you can find a combination of numbers that work using the commutative property of addition with subtraction. So, when we go back to our seats, I want you guys to use your number line and use any number you can think of. And I want you to try it with a partner. See if you can find a group of numbers to see that it disproves that it only works with addition. Okay? And then we will afterwards get back together as a class and talk about what we found. Okay? We're going to do this for about 15 minutes and then we'll get back together. Okay? Okay, let's go back to our seats, first graders.